Hello all, welcome to Ferdinand tutorials. I hope you're doing well. I hope everything is okay. So today I came with my material. I'm going to be teaching with this, so I hope you love it. So give me your attention, avoid every distraction. Anybody out there disturbing you, please shun them, put on your earpiece and give me your attention. This video is going to be interesting. Now, having known this, I do teach offline, and whenever I teach my students, some of them be like, I don't have the unit for this question. I'll be like, you should know it since you know the formula, since you know how to solve it. Why then don't you know the unit? They'll be like, sir, they didn't teach us in secondary school, or I've forgotten, like different stories. So I see that as a problem, and I've devoted my time to teaching them that, and I hope they're getting it. Yes, they are. So today I want to teach you about units and measurement. Now, when you hear about measurement, so measurement is the process of determining the amount of an unknown physical quantity by using a standard known quantity. So if I know that this is not known, I want to determine it. I don't determine it by my head. I use a standard known quantity to determine it. Now, you see that measurement can also be defined as the process of finding a number that shows the amount of something. Now, in ancient times, man was faced with the challenges of ascertaining the mass of electron, the distance from one point to another, the amount of rainfall, the speed of light. Now, when you hear about speed of light, you know that speed of light is 300 million. That's 3 times 10 raised to power 8 meters per second. So that's the speed of light, the speed of a moving body, and the importance of measurement was realized as they go. Now, he started using general method to measure the different physical quantities, and with them, he reached the perfection in measurement. Now, with the progress of science, it was discovered that those types of measurements were inadequate, which drove man to discover well-defined and precise methods for measuring different physical quantities. And with them, he realized the perfection in measurement. Now, there are units of measurement. When you hear about units of measurement, understand that units of measurement is a standard quantity used to express a physical quantity. Now, in time past, a multitude of systems of units used to be very common until the world adopted a global standard, which is the International Systems of Units. That's the one we call SI unit. So when you hear about SI unit, understand that SI unit simply means International Systems of Units, SI unit. Just like we have the IUPAC. When we're talking about chemistry, IUPAC, we say that is International Union of Pure and Applied Chemistry. So here now we say SI unit, International Systems of Units. So now, which is the modern form of metric system? Now let's talk about this physical quantity. We have two types of physical quantity. Are you getting it? We have the fundamental physical quantity and the derived physical quantity. Now, for those of us that don't know what is physical quantity, now a physical quantity is a quantity that can be quantified by measurement. So for you to know what a physical quantity is, you have to quantify it by By measurement. So any quantity that is quantified by measurement is what we call a physical quantity. So that is it. Now let's go back to the fundamental physical quantity. Now, you say that these are quantities that are independent on other physical quantities. Now, there are 7 in number. We have the length, we have the time, we have the mass, we have electric current, light intensity, temperature, and amount of substance. Now, length is measured in meter. That's the unit, in meter. Are you getting it? Temperature is measured in in Kelvin. That's K. I don't know if you are getting it. Mass is in kilogram. That's kg. Are you getting it? Now, we have electric current, which is in ampere. Time is in seconds. Amount of substance is in mole. Light intensity is in candela or CD. So these are the 7 fundamental quantities. Now we have the derived quantities. Now, derived quantities are quantities obtained from one or two fundamental physical quantities. That means when fundamental quantities join together, we call it a derived quantity. Derived in the sense that they don't form their own. They get their units from other places, which is the fundamental. So when you hear about the name derived, just know that this one is dependent on other quantities, which is the fundamental quantities. Now, example, we have the volume, we have the momentum, we have the force, we have pressure, we have power, and acceleration. Are you getting it? Now, general acceleration is in meter per second square. Now, for when you hear about meter, you know that meter is length. When you hear about second, second is in in time. Now, the next one there is force. Force equal to momentum over time. Now, the unit is kilogram meter per second square. So that is it. Kilogram is a mass, meter length, second is time. So these derived quantities are formed from fundamental quantities. So that is it. Now in my next video in this physics, I want to talk about derived quantity. Then maybe I will use my board and then we'll draw something. We explain some of these things and you understand enough of the theory. So we are going practical for my next class in physics. So I know you'll follow me through. So let's see again in my next class. Try not to miss it. Try not to be absent. We'll see again on Thursday. See you and have a nice day. Peace unto you.